Hi, I'm Nikos. Welcome to the National Technical University of Athens. Here we develop smart technologies for the networks of the future. For the last 30 years, the laboratory is doing research for the integration of distributed energy resources to the power system. Our research has been funded mainly by the European Commission through European Research and Innovation programs. We have developed several advanced algorithms for the forecasting of renewables, for the planning and operation of the distribution system, for control of distributed resources, applying centralized and decentralized control techniques. Our algorithms have been used in various pilot sites and also by the industry in Europe and Greece. Our aim is not only to develop these technologies, but also transfer them to knowledge in the university, but also in secondary schools through dedicated lectures. We have also used these technologies for electrification and also for the support of local energy communities in Greece and Europe. Overall, our aim is to develop technologies for the transition of the European system to a sustainable future.
Prototyping and testing new designs can be costly and time-consuming. We solve this by employing 3D printing technologies. In our lab, we print and test new designs for blades for small wind turbines. This is very important for our rural electrification group, since we have an activity that we go to remote communities, usually in developing countries, and we do workshops with the locals and teach them how they can manufacture with locally available material small wind turbines. This activity has also been transferred to our educational activities, where we, together with students, high school and university students, we perform these workshops. This activity was employed through Re-Empowered project, where we installed a small wind turbine at the Hydromadra Microgrid in Kythnos. The turbine was developed and manufactured by students of our university here at the premises, and then they went at the site and installed the whole wind turbine.
So how do you keep the lights on when there is a blackout? A microgrid is part of the distribution network that can operate both in grid-connected and islanded mode, which means that it can operate seamlessly when there is a fault in the upstream network. This is the laboratory microgrid, through which we connect photovoltaic panels that are present at the roof and wind turbine of the laboratory. So this is the windy boy, which is the converter that connects the wind turbine to the microgrid. This is the sunny boy that connects the photovoltaic panels to the microgrid. And this is the sunny island, which is the heart of the microgrid, the battery inverter, which is the one that takes charge of the voltage and frequency control in case of islanded operation. Moreover, we have different types of controllable loads that can be controlled through the SCADA system, where we also obtain measurements from the AC side of the microgrid and DC side. This system has been developed in the framework of the Microgrids project and is now used in several European projects such as ERIGRID 2 project.
Among the issues that we have on the integration of control and protection and new equipment power system is that we don't know the exact characteristics of this equipment. The manufacturers might not disclose everything. So part of what we do here is hardware in the loop. And hardware in the loop is a very powerful tool that allows us to test in real time industrial equipment or equipment that we develop. The backbone of hardware in the loop is a real-time digital simulator, which can run a power system in real time. And that allows us to connect in that simulator physical equipment like protection relays, controllers, or even through the amplifier, hardware inverters like battery inverters or photovoltaic inverters. And we use it here in the lab for various purposes. For example, cybersecurity threats can be modeled through this simulator. We have a project called R2D2 that is on that topic. And of course, controllers that we develop for microgrids are first tested here in the safe environment of the laboratory before moving them to the actual sites. So we have a project called Re-Empowered, and this is the procedure that we follow for testing and installing the microgrid controllers that we built in the microgrids in Greece and India.
An important tool to increase the energy efficiency and support the integration of renewables in the power system is demand response, namely to control loads and appliances inside the household or in a microgrid. Our laboratory is doing research on distributed control algorithms and artificial intelligence that is used also for applications for demand response. An important part of demand response is the load controller, the device that hosts our algorithms and can control the various appliances. Here we can see 3 generations of load controllers used in various research projects that the laboratory participated. The first one was developed in the More Microgrids project. It was installed in Kythnos. It uses power line communication to control the loads. The second one here, developed within the Smart House, Smart Grid project and the DREAM. It has a screen that can inform the user and the house owner about critical information, about the consumption, the cost, etc. Finally, the last one, which is the most advanced, it was developed in various research projects like Nobelgrid, WiseGrid, and now it's also used in the Re-Empowered. It's developed by ETRA, and it has a small internal computer that can host various applications. These applications could also be our distributed control algorithms and also the machine learning algorithms.
Thank you for joining us in our lab. See you at EU Project Zone at Enlit Europe.